My name is Christian Tirakonda, and I'm a principal engineer in the technical marketing and product team, Crosswork product team. And I'm joined with my colleague, Paul Arosio, who's also in the same team, focusing on service assurance uh, functionality in the Crosswork portfolio. Um, what we'll be covering is the new feature that we've added and going to a demo, right? Um, so far, what we showed you was if you remember the introduction session, we said Crosswork is intended to solve transport network operators problems, to service turnup, to do complicated SLAs, fine-grained SLAs using traffic engineering, and get visibility, right? You can see the visualization that you saw that I just presented, as well as Sujay for SRv6 and some of the advanced SR things like pre-said. Now all of that's deployed, you can see it, but how do you deal with incidents that invariably occur right after you turn up a service to and hand it off to a customer, right? The state of the art, uh, you know, depending on from where you're looking, you can even use our term legacy technology that is pretty widely deployed. Is that you have independent stack to do orchestration and service turnup, and then you have a fault management system that collects your traps, logs, things of the nature, and then you have a some kind of an active assurance system that may be sitting and sending synthetic traffic and verifying that a service end-to-end reachability works, treating the network as a black box, if you will, right? All of those things are good, but end of the day, you still don't know, right? If you get a particular warning or error or something comes up on any of these subsystems, is it real? Is it important? Which customer is impacted, right? And for premium customers, usually there is some custom work done just to assure that, and that doesn't scale well, right? So the big ask is that now that we have a controller, we can do service turnup, we can do visualization. Can we also actively monitor it? And can we monitor it in different ways, right? So not only we want that the service is working end to end, we want any kind of fault or logs or traps or anything that a device emits as a fault information be mapped to a service automatically. The automatic is a key, right? Usually customers have mapping servers where they say this sub-interface belongs to this customer's attachment circuit, and so whenever you get a trap with that, then give me this customer impacted signal or message, or text me things like that. But that doesn't, like I said, scale well because you need to have another software developer come and build it. What we have done is in CNC taken an approach that when we provision a service, we will also monitor anything that is important, from verifying that the service is up. And when those things go down, we can actually indicate to you that that service is impacted. Once you have that kind of capability, you can actually start monitoring other things besides just the, let's say, control plane, things like that, right? We can also monitor SLAs, right? Can you guarantee that you're still getting the same end-to-end delay or jitter or packet loss counters, right? You can collect telemetry for that particular traffic that belongs to a particular service, a VPN customer, or a transport customer, and actually measure that and compare it against threshold and say that your customer A has a threshold violation, or or the threshold violation has cleared, so that your ops staff can react. Right? So you do that as well. Typically, you can do that using external synthetic traffic probing kind of technologies, right? You can send TWAM sessions from your external probes, treating network as a black box. When that traffic fails, you don't know where the problem is, right? So you do need some hints, which is the third item here, meaning, can you tell me that what else happened at the same time when I get, my packet loss counters go up? Can we do that, right? So that we can actually now have the response, right? Meantime to know can be actually reduced so that they actually get a hint that not only that customers' traffic is going to experience some degradation, but we also saw these errors that are mapping to this particular service. Maybe that helps the staff to debug and fix it, right? So those are the things, right? We want to look at, which is we give the service impact at a service level automatically, give extra KPIs that are basically experienced by customers' traffic, and capture knowledge, incidents, putting both together, right, in the context of service. So I won't go to this, but the only thing I would mention here is that there is actually a internet draft for service assurance for internet-based networking. So if you go back to the show you the draft. So there is a draft that's if you're not familiar with it, you can look at it. It's getting close to final stages. It's actually authored by quite a few vendors as well as service providers. And this kind of documents some of the approaches that can be taken. It's an architectural draft, but the concepts are kind of adopted in our implementation of it. And I wanted to scroll down to this particular picture here in the ITF draft, where the idea is that you have the service orchestrator that's creating the config of the service, which is usually lines of config or netconf, going to routers, implementing some kind of a VPN technology, and that's what is pushed to the router network system at the bottom. And then you have the sane orchestrator, if you will, the architecture component, which basically takes the config DB, calculates the things that are relevant to that particular service, and then subscribes using a collection infrastructure to those KPIs, which then come back from the router. It's collected, it's put in the context of the service, and then you indicate to the service status, right? So that's basically what I'm going to show you in the demo. So let's go back here. The outcome is, of course, reduce the time to detect issue as well as remediate, and also improve customer experience. There may not be any fault, but yet customer is getting packet losses. So you want to proactively go ahead and jump in and resolve it. So, but the main thing is the customer, the service provider, the operator needs to know that's happening. One of the ways we do that is basically by building a rules engine that actually knows that for a particular type of VPN, what KPIs are relevant. Think of it as a service dependency graph or service assurance dependency graph, meaning for this thing to be healthy, it depends on all of these things, right? X, Y, Z, and X depends on A, B underneath. So it's a dependency graph is a technical term, but it's basically a tree structure. At the final bottommost thing, it'll be some kind of a operational key performance indicator, KPI, right? It could be a equivalent of a show command that you would do, show BGP, neighbor state. It could be a Y1731 packet loss counter, things of that nature, right? So there's a bunch of logic sitting here that is calculating what of those things you want as well as consuming those. So that's the piece that the service assurance functionality in CNC is building, and this is new in 4.1. We showed some previews in 3.0, but in 4.1 it's a shipping functionality. So now this is my demo, right? I'm just I wrote it in a way that you would want to look at it, right? If you're an operator and you have CNC in front of you, what is it that needs my attention today, right? Let's look at that first, right? That usually is a VPN of some kind that has some kind of a problem. So I need to be able to drill down to that really quick. And then when I look at it, I need to know, something that tells me that what could be wrong. That's what we call a symptom, because we are not sure. I mean, it's not an AI ML engine, right? This is basically a rules-based engine. So we are going to detect something's broken. It's things that you have coded into the rules engine, right? And we'll talk about that. But that the operator who is staring at screens and keeping the network, keeping the lights on kind of guy or person, he needs to know quickly what is the symptom, so he can start, or he or she can start drilling down into that piece. Now, what is the history for this VPN? History is sometimes indicative that if something has been flapping, going up and down, it may be, it's an easy thing for humans to now say, maybe it occurred again, right? Maybe the things are matching the occurrence, and it reduces. The idea is to reduce the amount of time customer service is impacted. So let's get all the tools that we have for it. History is a good one to visualize. The next few things are, where are the rules coming from, right? So if you look at what an operator is doing, right, the first line of defense, That person may not be a technology expert, right? There are escalation engineers, architects, and engineering staff. They are the knowledgeable people. They test and build exact VPN configuration for the service they want to sell or deploy, provide to their end consumers. They know what exactly you should check. Typically, these are things like, again, repeating. You can get that through show commands, right? For a particular type of technology, there's a bunch of show commands or SNMP MIBs that you want to query, or nowadays GRMI OpenConfig operational leaf items that you want to query, and that will tell you whether that particular component or piece of that service is up or down, right? However, all of that needs to be put in the system a priori, and that's what we call as heuristics package. So when we ship CNC, we put a heuristics package for the sample VPN configuration we put in the product. Now, remember, the configuration can be extended. We saw how we adapted a Junos router in one of the sessions. It can also be extended to do different flavors. This is meant to be done in field by customers or professional services and partners, right? So heuristics package is a companion to orchestration, so you can also extend that. So that's the topic we'll cover. I'll give a brief because it's a very detail-oriented topic. We did present in the developer days how it can be extended. We did a VPN model that's usually published in our training documents for NSO. We just took that and we showed how you can implement heuristics package for that. Anyways, so let's get started with the demo. I'm going back to my browser. Hopefully it hasn't timed out. No. Okay, good. So here, so this is the setup that I'm going to use, and this is the dashboard. Again, you might remember this from the earlier session, but there is a portion of the screen that is basically traffic engineering, and there's VPN services and VPN service health, right? So VPN service health is, by the way, an optional component. You need to install something independently to get that. So that's called the service health, right? You install the bits, and when you install those bits, you get the dashboard, this part of the screen lit up, and and then you enable monitoring on a service by service, so that you choose which ones you want. As you can see here, we actually categorize here and show you that of the two services monitored, one is good, one is degraded, right? So you just go ahead and click here, and it drops you down with the VPN services view, right? So here, in the VPN services view, what we've done is here's where your thousands and hundreds of thousands of VPNs will be listed. But what we've done is we have applied a filter that checks for anything that's degraded already, right? And basically, you end up seeing this particular L3 VPN as down. So let's get rid of this filter just to show you that there are quite a few VPNs here. But there are only two that have service health monitoring enabled. L3 VPN, VPN 101, and L2 VPN, this one here, which is all good, but the L3 VPN 101 is down. Now we want to know why, what is the symptom? What are we detecting? So you can go ahead to view details, and you can see here that we actually are saying that eBGP session to neighbor 30.1.102 is not up for device node 5 VRF VPN 101, right? So this is a L3 VPN, so it has VERVs and then Ps. So we can go ahead and actually enable this view, and you can see here that it has this particular peering relationship with the CE is complained as down. So basically, now we know that something facing CE is down, right? And it's a eBGP session. Now let's go ahead and look at a few more things by going to assurance graph. This is where the dependency graph that's in play for this particular VPN is listed or shown, and then all the symptoms that we're detecting right now is listed here. Let's look at first this side. So there's a when we talk about dependency graph, what we do is we take a L3 VPN or some kind of transport service. We have this dependency graph where each of these things are called subservice. Think of it as a bunch of logic to do one check, right? And it can be hierarchical, meaning checks underneath can feed into another check that consumes that, and end of the day we want a Boolean healthy, not healthy kind of indication, right? So that's what these things are doing. This is the error message or the symptom message we got, and this is the check subservice eBGP neighbor health, and I'll show you where what that means here, right? So let's go ahead, and actually you can click here and see that, right? So what we are doing here is that we are checking that the BGP session should be up, right? It came back as false. And how did we check the BGP session? There is actually a way to go query the metric that indicates a BGP session. And this is on the PE node 5. The neighbor IP we're looking for is that, and we are looking in the context of a VPN, right? The result of this action, which is collect the metric, was supposed to be BGP state active, but it came back to be, actually it came back to be BGP state active. Now, BGP protocol, the way it's documented is funny because when BGP is active, it actually is not a good thing. For most things, active is good, but for BGP, active means it's actively trying to set up a peering relationship. Established would be a good thing, but active is actually means that it's not up. And so we are getting active, but it should have been up, right? So that's the problem here. Let's look at what happened. Yeah, let's zoom in a little bit, and you can see here. Let me push this out to the side. We are doing a lot more enhancements of this kind of visualization because, as you can see, the number of checks can increase quite a bit, and then we have to repeat this check on every PE, right? So this is a check that's failing, which is PEC route health and the BGP neighborship health, right? This BGP neighbor health is a VP and V4 iBGP session. This is between the PEs or the PE and the route reflector. And if you have SR policy binding, then we can also check PSEP health. By the way, when I say we can check, it's basically whatever you put in the heuristics package. You can take the out of box, you can change it to whatever you want and import it, and I'll show how to do that. Interface health, this is a PEC interface health, and then it's repeated. Here's a VRF reachability to peers. So here we are checking whether we can get, for example, the if on my VRF, do I see a route from remote VRFs, right? That kind of checks we can do. A lot of good checks here, and they're all easy to understand. And we'll, when you look at the heuristic package, it'll be very clear what these things are, right? Now that I know that the BGP session is failing to a particular CE, what's been the trend of that, right? I mean, has it been happening before, or has it been, is the first time, or what is the previous history? So that in the right corner we have show history. Let's go ahead and take a look. And you can see here there's a visualization. It's kind of a heat map-ish kind of a widget. We are still, I guess, fine-tuning how the appearances are. And you can see it was good here earlier today, and then it went down, right? So you go ahead and click that, and let's get this view back. Move some things around here. Okay, so this, so now we are saying that EB session is not up. What we provide you is that for any KPI that triggers a bad health or a degraded health situation, we can tell you what the raw data for it is, right? For the last 24 hours. We are not a storage archival system. What we keep collecting is we keep throwing away after 24 hours as well, unless there is something that's triggering a symptom that is, that means something is degraded, something that we have to flag to the human operator. So to help them debug further, we are going to give them the 24-hour data. But we do have a way to archive the data externally for your archival systems. And so we have that as well. So as you can see here, it's been up for a few hours earlier, then it went down, and then it came back up, and then it has gone down again. So there is a lot of visualization widgets here. You can actually zoom in and pick a certain time zone, and you can see that it was up earlier and then went down. And so this basically helps you figure out, what's going on in the past. Maybe the CE, it's an unmanaged CE, so maybe the customer himself or themselves are doing some things here. So they may need to call the customer and say, hey, your CE went down. Most likely, they are the end customer is doing something. If not, they should probably call. Anyway, your SLA is protected, right? It could be that the PEC link is down, but you would have got other alarms here, right? Because we're actually monitoring the PEC link as well. Here's where you could add a little bit more things, like in the nature of TWAMP sessions and IPSLA sessions and so on. So that's the historical view. Now, talking about KPIs and TWAMP sessions, for example, we can actually show you a different example. For that, what we have is we have something called a config profile. This is where the KPIs, the number, the gauge, if you will, in SNMP MIBs, they're called gauges, right? CPU, packet loss counters, those things. Those are called gauges. Those can you can set you can ask to monitor some of them, and then this is where if you have a TWAMP session, you can actually monitor those and count against thresholds. In for CNC 4.1, what we did is we built the Y1731 based monitoring for L2 VPNs. For L3 VPNs, we decided not to build TWAMP in the out of box because the embedded TWAMP, the router TWAMP, the scalability for different platforms, the IPSLA, there are usually, packet packet per second limitations of how much you can originate from the router itself, right? The embedded monitoring system. So what we're trying to do in the next few releases is to integrate with an external packet monitoring systems, synthetic packet systems, and then consume those telemetry in the same context. So we'll be announcing some of that capability as well. But right now, as you can see, for L2 VPNs, we are doing embedded monitoring using Y1731, and we can count jitter RT, round trip, latency round trip, packet loss dash source, or packet loss source dash unidirectional counters. And you can see that we have a assurance graph here for that. And even in the front view where we go into this, details, you can actually see the summary of the customer's SLA. Are we meeting it or not? We are meeting it because we're all green here. And here's exactly what we are comparing against, right? The latency, router threshold, and things like that. So interestingly enough, this is getting a lot of good, feedback from our customers. They like what they're seeing. Even our large enterprise customers that see it, they really like it. So getting into a little bit of what is happening behind the scenes, right? So one of the key points to remember is that service health module in Crosswork, it looks at the actual config. And if you go back here, there's a heuristic package. So how does it know what to look for, right? The translation of the config data to the operational data for that particular VPN is done by using a set of rules that are that capture the knowledge. To think of it as a troubleshooting knowledge for every VPN. You capture it, you put in a particular format. The format is very what we call as low code, meaning it's not, you don't need to hire fancy developers for it. A network engineer with a little bit of a savvy, editing skills can get by for most part. There are some things that you may need to use Python for, but for most part, you can see here that it's basically a JSON file, and it looks at the config DB, right? So the rule that was applied for L3 VPN is called rule L3 VPN NM. By the way, you can customize it. If you cancel the system, you export it. You'll end up with a text file, and then you can import it back. This is I imported back just before the demo, an example of this. And you can basically take this and you can copy to clipboard, right? And then you can edit it, any which way you want, right? So you can just say, so this is the JSON file. There are JSON editors that you can use to edit those, and it's all text files, right? That's the point I was trying to make. That it's not coding. It's a what we call as low code system. And let's go back here. So, for example, this L3 VPN network model, how does it know which service to apply? It goes and does something called XPath query. XPath is nothing but a filter technology that is used with XML, right? If you have an XML document, you can write an XPath query to get certain nodes out of it. And it's well documented. There are so many freeware tools. If you go and do an XPath query tool online, you'll find so many. You can cut and paste, the service config. And where do you get the service config? For getting the service config, you would go to NSO, right? And you would look at. So this is the NSO, and then you would log into NSO. So this is where it's not just a network operator, right? This is somebody who's comfortable with doing administrative functions and developing the NSO packages, that kind of person. So we are looking at show configuration, L3 VPN network, VPNs. This is the way to get the VPN config XML, right? And you get this XML, and you can see here that the rule is that match any VPN that has that particular XML node, right? So that's what this line means, saying that this rule will apply to a VPN that has this particular pattern match. And then if you come down here, it has dependencies. Actually, you can see there's actually 8 dependencies. Each dependency is one of those circles, actually, right? A subservice, as we call them. And then each subservice needs some data to be extracted from config.db, right? And then these are again expats. You can do a device as device key. I mean, this is the XML expat notation to get it out. The value that this will be returned will be, taken in by service health, and then it'll be fed to the subservice to go get to do something, right? And then this is a VPN service, VPN ID. So in summary, basically, in this particular case, the VPN 101, it gets the XML document that is the service northbound service creation. And it also, so you can see there are, bunch of paragraphs of XMLs, if you will. And then there is what we call as modifications, right? This is the stuff that goes to the device. So once you create a VPN using the Yang model that is device agnostic, the system actually calculates the device-specific configs, right? You may need to look at the device-specific configs also. So the command to get that in XML format is this. So these, if you look at this, you'll see that you get a whole XML output of what will be pushed into the device model. Now, if you are doing a non-Cisco device like a XC, even Cisco XC instead of Cisco XR, these models will be different, right? So you have to accommodate this. But the good news is that the rules layer is kind of agnostic, meaning if your device is a XR, XC, Junos, whatever, you already imported the device inventory, and then you have actually onboarded it. The rest of it, if you have the rules for each of those types, it can handle it, right? The point I'm making is that this is highly extensible. You need to capture the knowledge of how to troubleshoot, and then you have to create equivalent expats pattern match from config.db, and then you have to go back here and you have to create the subservice logic. Let's look at eBGP neighbor health that failed. The eBGP neighbor health is going to take device for neighbor IP addresses and send it to this subservice, right? This subservice will actually do some logic here. The subservice is called subservice eBGP neighbor health system, right? We are still in the rules module. The rules module is going to say that for this L3 VPN, eBGP neighbor health check is required. For that check, I'm going to look at the config and parse out these items and then send it to the subservice. And where is the subservice? It's actually documented here. So you can do a eBGP, neighbor health. And if you open this, again, it's a bunch of JSON, notation. So it's a text file basically, and then it actually has a way of writing saying that go get the actual metric from, in some way. The end of the result of that should be that I get the BGP session state, and if the BGP session state is up, this is healthy. If it's not up, it's not healthy. And then you can give some weightage about how bad the error is and things like that, right? Now, where did the metric itself get defined? Let's go and take a quick look at that. That's coming from here. So let's see VRF. I think it was called VRF session state. And this one, the input is that a router name, neighbor IP, and the VRF name comes in. And here you will see implementations. Here for iOS XC, how to get that information through GNMI. Here's the operational leaf, and here are the extra filters that you apply on top of what you get. And then for XR, and then you can, in theory, have any other vendors' routers here. What the data that you get back may not be exactly identical. In one case, if you see here, there is some fix-up being done, right? So you can see that BGP state established coming back from iOS XR is mapped to up, right? And then in this case of iOS XC, FSM established up, right? So those kind of fix-ups can be done. So this module, again, like I said, is mostly editing on editors. You need to know what you're doing. You need to know the operational paths using the iOS XR documentation or XC documentation, and then you keep adding to it.